Hello. This will be about 4 or more dimensional. To start, we have 3D. This is about Euclidean 3D so far. So, each plane is perpendicular to another line, and each dimension axis is perpendicular to each other. So, what if we had another one of these? Connected in a linear fashion, this could be considered 4D.
Were you talking to me?
No.
No. Okay. All right. Move on up there. See if I can get
But that is not the end of the story. In this case, we have something like this going on. X, Y, Z, but then we could consider it also like this. X, Y, W, with W being a fourth dimension. But wait, we could also do Z, X, W. It's a whole thing, and where each is perpendicular to each other. So, we have a plane in per each set we could make out of all of this. So, if we have X, Y, Z, and W, that would make 1 XY, 2 XZ, 3 XW, and then we have other ones too. Any combination you can think of on this is it's existing all together. So we have YZ2, we have YW, and finally we have ZW. Now these are all possible planes we could use. They are all perpendicular to each other. Now, what about if we did circular? Now, definition of this would be something like x times x plus y times y equals some constant. Now, if we did well, and also now we have a two-dimensional thing of spherical. What we have to add here is z times z plus and we continue. That's 2 dimensions. But what if we wanted to add a third dimension? What we can do is add in w times w and we get this thing extruded in a 4th dimension and another axis of rotation, so now we have 3D. Okay. But that's not all. There is also something called hyperbolic. For that, I have to look up. It's called a hyperboloid. And my answer is a hyperboloid is an open surface generated by revolving a hyperbola about either of its axes. It is a surface of revolution and can be generated by rotating one of the 2 lines that are skew to the rotation axis. If the transverse axis of the surface lies along the x-axis and its center is at the origin, and if A, B, and C are the principal semi-axis, then the general equation of the surface is expressed as x2 divided by a2 plus minus y2 over b2 minus z e2 equals 1. Let's see what this length brings me to. So, we have x times x over a times a plus y times y over b times b put plus minus there. The last one is just minus. Oh, and for this it would be technically these because we're dividing by them all. That is for a 2D. Basically, a bunch of hyperbolas connected together. This is what is called hyperboloid. Now, that's for a 2D of hyperboloid. I have confirmed with Wikipedia that it is correct. That's what I wrote. It can also be equal to -1. But it is x squared over a squared plus y squared over b squared minus z squared over c squared equals 1 or -1 on Wikipedia. Let me see what else we can find. Here's some interesting stuff. A straight line in hyperbolic end space is modeled by a geodesic on the hyperboloid. A geodesic on the hyperboloid is the non-empty intersection of the hyperboloid with a two-dimensional linear subspace, including the origin, and of the n plus one dimensional Minkowski space. If we take u and v to be the basis vectors of that linear subspace with b in parenthesis u n parenthesis equals 1, and replace u in that with v. Let me draw this. V u equals 1, v equals -1, and there's another thing. V u v u equals 0. This is its definition. Anyway, I hope you enjoyed this. Bye. Oh, maybe, maybe, maybe.